Hello everyone. I'm here again. So I'm going to be using this video to explain to you how the Bash assignment, how to go around the Bash assignment. So first of all, you have to navigate to this URL for the assignment, which is on GitHub, right? So this is the instructions of the assignment. You just have to go through all the instructions, and then this is the instructions for how to clone the Git, fork the Git repository, clone it to your machine, and then do the work. So these are the assignments. You're going to be required to create the user.info, user_info.js file, and then the system checks, file manager, backup, and process monitor. So let's just go straight into how you're supposed to go around this assignment. So first and foremost, you're supposed to come and click the fork button on this repo to fork the repo to your GitHub account. So I think I've explained how to do this previously. So forking this to your GitHub account will take you to your own account and create a copy on your own GitHub account. This I have already done. So the next thing I'm supposed to do is to clone this repo onto your local machine by just copying this URL, right? And then go into your Ubuntu terminal. So after coming to your Ubuntu terminal, all you need to do is to use the git command, git clone command, and provide the URL to your repo. But make sure you have authentication, either SSH or access tokens. So if you're using access tokens, you just need to provide access token here, and then use an @ right? Use an @ and then the URL to the Git repository. So I've already done all of that, so I'm not going to be doing that again. So after doing that, you're going to have the copy of the repository inside of your working directory. All you need to do is to change your directory into the folder of the assignment. So when you run the ls command, you notice you only have a readme file. When we come back to the repo to check out the instructions, you see that you're supposed to clone the Git repository after forking it, which you have done already. So you don't need to create a new branch using the git checkout command. So let's do that. Checkout -b, and then the branch name, which is start with future, and then your name. So in this case, I'm just going to be using student, so that you can substitute this with your own name. So when you do the git branch command, you see that we have the main branch, which is the default branch, and we have a student branch, which we're going to be working on right now. And this is the branch that I created earlier. So I'm just going to be using this branch just to illustrate to you how to go about this. And while creating your own branch, you should substitute the student with your own name. So let's go back to the instructions. So the instruction is telling us that we need to create a script folder, right? And then make all the script within it executable. And then when we are done with all the work, we want to use the git add command and then commit with this message, and then push back to our GitHub repository, and then make a pull request. So we're going to start by creating the folders, all the required folders. So we are going to be needing the script folder, mkdir scripts, and then along the way you're going to notice that we're going to be needing a logs folder. So I'm just going to create them now all together, and then we'll also need the backups folder. So I'm going to use the 3 command to see. So you see we've just created. So you see we've just created the backups, log, and the script folder, and then this is the default readme file. So let's go back to the instructions. The first instruction is for us to create the user.info.sh script, where we're going to be handling prompting of the user to insert their name, age, country, and then we'll do some validation for the age, and then output a greeting message, and then we want to check the category of the age of the user, and then at the end of everything we want to log to a file called user_info.log in the logs folder. that we just created. So let's go ahead and do that. So I want to change into the script folder and then create a user underscore info.sh file. So since I've already created this file, I'm just going to go back to my GitHub repo and then go to that script folder and then go into the user_info.sh file. So this is the file that I need to solve the first part of the assignment. So I'm just going to copy all of these scripts and then take them to my script folder in my terminal. So in case you copy and paste in your UI editor and you notice it was scattered, you just need to reduce the spaces in between and just try to format it properly, and then it will work as usual. So I'm just going to explain how this code now works. So at the beginning, we have our bin bash, right? And then we have our log file. So our log file is where we're going to be saving all the logs or all the outputs from this file. So it's going to be in the folder upwards, because we are currently in the script directory, right? So we want to go one folder upwards and then enter into the logs file and then save into the user_info.log file. So what we want to do is we want to prompt the user to enter their name, age, and then country. So let's go back to the instruction and see. You see, we're supposed to prompt the user for these 3 variables. After prompting them, we just want to state them in these variables, and then we want to do some validation. What validation are we doing? We want to check if these files are empty, right? So if these variables are empty, that's the name, age, and the country that we've just collected. If they are empty, we just want to encode this error message, and then we pipe our output and then give it to the T command, which then helps us to plug it into our log file, which is this file. And what we're going to be doing next is if these files actually contain values, we don't want to echo this. We just want to move on to the next if condition, and then the if condition allows us to do the validation for the age, which is one of the requirements here. That is validate age must be numeric. So to do this validation, we have regular expressions that we are going to be comparing the age to, and then this will return true if the age is actually true. If the age is actually numeric. So we then want to just negate this and say, so if the age is not numeric, we want to echo age must be numeric and then log this to our file. And then we also want to exit with a status code of 1, which indicates that the script need to be exited, right? And then with an exit code of 1, which means there's an error in the script, which is this error we are sending out. Right? So, but then if the age variable is numeric, we don't want to run anything here. We just want to go ahead and check the category of the user. So if the user, by now checking if the user is less than 18 years old, we want to set their category variable as minor. Else if they are less than or equals to 65, their category is adult. Else. So this is the default condition. Else we just want to say they are senior, because definitely they are going to be 66 and above, because they do not match any of these conditions. They want to end our if statement right here, and then the message that we're going to be sending out, we just want to create another variable to hold the message, and then we just want to say hello, the user's name, their country, and then you are maybe an adult based on their age category. All right, so we just want to echo this message to the user, and then use the T command to append to this log file. So we just want to save, exit, and then run the file and see how it works. So yeah, let's use the bash command. So it's prompting me to enter my name, and I say Muhammad, right? And then my age, say 20, right? Currently I'm from my country, I would say I'm from Nigeria. So it says, hello Muhammad from Nigeria, you're an adult, right? So so definitely that logs is going to be logged to our log file also. Let's use the 3 command to check out our log file. So you see so we just created a log file right here with the name logs.userinfo.js. So you don't need to create this file. This file is going to be automatically created for you. All you need to do is all you need to have is the folder part, and then this file is going to be created automatically. So let's cut the content of that file and see the log. So you see this is the content of the file, Muhammad, this, and this is what was printed on the terminal. So it has been logged successfully. So let's quickly go to the second assignment, which is system_check.system_check.sh. So system_check.sh is going to be performing some kind of system checks around the DDX usage, memory usage, CPU uptime, CPU utilization, and then do some warnings based on the percentage of the consumption of the disk. And then as usual, we're going to be logging our report in a file called system reports, and then the timestamp, which is going to be the date. So let's quickly go to the terminal and create the file for that. So the name of the file is going to be system_check.sh. So I just want to go back to my repo and then fetch the code from there, since I've already written them. So I just want to copy this code right now. Come back to my terminal and paste the whole code. So as you can see, I'll have to remove these trailing hashes, so I'll do that quickly. Yeah, so I've just removed the trailing hashes. So I'm just going to explain how this file works now. So let's just look at the requirements once more. So the requirement is that we are required to display the disk usage, memory usage, and then the CPU load that's using the uptime, using the df command and then the free. Alright, so let's look at that. So to do that, we want to just make sure we have our date timestamp first. So to do that, we just need to add a bracket sign and then the date command. So this date command is going to provide the full date variable, but then what we just want to do is we want to format this to just give us only the year. That's why I'm using the percentage y sign to format the output of the date. So I don't want to have a very long string. I'll just have the year only, which is going to be 2026, and then I'm going to be saving in the date variable. So our log file is going to be inside this file, and then adding the date, just so that the name of the file will contain the year 2026. So what I want to do first is I want to echo system report, because that is what we are going to be doing, and then we're going to be logging that into our file also. This is our file, and then we just want to echo disk usage. So after echoing the disk usage, we want to use the df command. The df command will now show us the disk usage of our system. So let me quickly demonstrate how the df command works. So this is the format that is going to be printed to our screen after completing the script. So the df command will show us this information, right? And then it's going to pipe or log this using the T command is going to log this information into the log file. So secondly, we want to use the free command to check our memory, and then we want to pass that information to our log file. Thirdly, we want to use the uptime command to check the load of our CPU. Right, so we don't need to show all of this command. Let's just quickly run through it. So now we want to warn the user. So the next requirement is for us to warn the user if the disk usage exceeds 80%. Right, so how do we do that? We want to create a variable called disk. We want to create a variable called usage. And then within that, we want to use the df command. The df command will give us the disk usage right from the root directory. And then we want to use the awk command that is going to be, select the first row. So let me just run the df command just so that you can see. So this is the df command. This is exactly what this first part of the command is going to be returning. It's going to return these 2 rows containing these informations. And then what we want to do next is we want to use NR option to select the second role. So the second role is going to be selected. We don't want to select this header at first, right? We don't want to select this header. We just want to select the real information, which is the second role. So after selecting the second role, we want to use the print $5 to select the 5th role. So this is the first role, 1, 2, 3, 4, 5, and this is the 5th role, right, which says the usage is what 1%. So after selecting that piece of information, we want to then pipe the output to the set command. So the set command is now going to search within this output, which is 1%, and then remove the percentage sign and replace with nothing, right? So after that, we're only going to be having 1 right here. So only 1, the number 1 is going to be the output, and is going to be stored within this usage variable. So we now want to check if that 1% is greater than 80%. So if it is greater than 80%, we want to warn the user that their usage is above 80%, and then log into to our log file. So what if 1% is not greater than 80%? We don't want to run any command. We just continue the process, and then we don't need to warn the user since their usage is way below 80%. All right. So the next thing we're going to be doing is let's go back to the instruction, and then we're supposed to save our reports to the logs file, which we have been doing. And then the next thing we're going to be doing is to count the total running processes. So how do you count the total running processes? So we just equal total running processes, right, in our output, and then we want to use this command, the psaux command, which I'm very sure that we're all familiar with this command. This command shows us all the running processes, right? And then we want to pipe our outputs. This ps command prints to the terminal, so we want to take that result and then pass it to the wc command, which is the word count command, and then do a count the lines, right? The -L will now count the lines of the processes, right? So to now count the total number of processes, because they are going to be displayed line by line. So we just count that, and then we'll log it to our log file, which is just going to be a number. If I have like 50 processes running, it's just going to log 50 and then print 50 to the terminal. So the next thing we're going to be doing is to display top 5 memory consuming processes. How can we do that? We just want to log this at first. Top 5 memory consuming processes using the echo command, which is just going to be like our header, right? And we just also want to log to our file also. Then we use the ps command here as well, using the ps command aux to list all the processes, and then we want to sort these processes based on their memory column. So let me just run the ps command so that you can understand what I'm talking about. So the PSAUX command displays all of this information, right? And then it has a header that says this is the column for the users, the process ID, the CPU utilization, memory utilization, and then the start time, the time it's consumed, and then the command that initiated the process. So what we are interested on is to we just want to see the processes that have the highest consuming memory, right? So we're going to use that to sort our results based on the memory column. So adding the because when you just use the sort option, it's going to sort in ascending order, right? So using the dash command and then the name of the column will sort in descending order. So the highest consuming memory processes are going to be listed first. So after that, we're then going to pass this output to the head command. So the head command will now take the first 5 lines, the first 6 lines, which is going to be 1, 2, 3, 4, 5, 6, right? So because we have a header, right, and then the 5 processes that we're supposed to select, making it 6. So that's why we're not using the head command to select only 5 rows. We are selecting 6, which includes the header. So after that, we want to pass result to the T command and then log that to our log files. So I want to save this file right now and then run the command and see how it works. So you see we have our system report, the fixed usage information, the memory information, the CPU load, the total running processes, right, and then the total running processes reached at 5, and then the top 5 memory consuming processes. So and then I'm pretty sure we have logged all of this output into our log files. Or we can use the 3 command and see if we have a logged file. Yeah, we have a system report file that we can cut and see if it matches our output that was outputted to the terminal. Yes, it matches. So this is the content of the log file. So we're done with that number of the assignment. So let's go on to the next one. So next is our file manager. So this script is going to be used to create a mini file manager, right? Mini CLI application that is going to be used to create, delete, list, and rename files. Right. So this is the example usage. We're going to invoke the script and then use either of this and then provide the file we want to work on. So let's go back to our script and then copy the file manager script that I have created beforehand. So right now I want to use the vim command to create a file, and that's called manager, the sh file. Then I'm going to paste the script that I just copied. So in case your editor also does not paste this correctly, you just need to go through each line and remove the extra spaces. So I'm going to quickly explain what this file does. So our file manager.sh file is supposed to act like a mini file processor, like a mini CLI application that is going to take in an action, right? So we're going to, while calling the script, this is how you're going to be calling the script, the name of the script, and then use a create to create a file, and then delete to delete a file name that you provide. This is going to be optional, right? Because it's going to be useful when you are renaming a file. So use create and a file name, delete and the file name. List, it's only you just need to provide the list command for listing files, and then rename, you need to provide 2 file names. So let me go back up, and so we start with our bin bash, and then register our log files where we're going to be logging our output, and then our first action is going to be the create, or any value we're going to be passing is going to be in our first positional parameter, and then the second value that is going to be passed in the positional parameter will be this and will be saved as file. So in the first case is that the action is going to be 3 different types of actions that are going to be performed, which is going to be create, delete, list, or rename files, as the case may be. So the best candidate for us to switch between the values, or to compare this variable against the number of options, is to use this case operator, right? So we're going to be using the case operator to check in case if the user writes create, and then pass in a file name. We want to check if that file is a file, right? Using the -f, we want to check if it is a file. So if it is a file, that means the file exists already, right? So what do we want to do? We want to say the file already exists, and we want to echo that and then log that into our log file, right? Else, if the file does not exist, we want to go ahead and create the file, right? What command are you using? We're going to use the touch command to create the file. After creating the file, we're going to log this to the terminal, and then log this or append this into our log file. So in case, then we close the first case statement, right? So the second condition is the delete. So if the user provides delete, we want to check if the file they provide is actually a file, and if the file is available. If the file is available, you then want to use the rm command to remove the file, right? And then echo file deleted, and then log that. Else, if this is not a file, that means the file does not exist, right? If this is not a file, we just want to echo back file does not exist, and then put in the log. So the next condition is the list. So if the user provides a type in list, we just want to so the list, when the user is typing the list command, the second variable is not needed. So right here, they're just going to provide list, and then a variable, a second or third variable is not needed. So what we're just going to do is to use the ls command, and then pass the flag lh, which is only going to list the content of the user's current working directory, right, in a long list format, and then in the human readable format. So we'll close that that section of the case, right, and then move on to the next condition, which is rename. So if the user wants to rename a file, so definitely they are going to be providing a third variable, right? And then we'll just take in that third variable, and then check if the first variable file, right? If the first variable is a file, we're then gonna use the mv command, and then rename the file from file to new file name, right? And then after that, we want to echo a renamed file to this new file, and then log that into our log file. Else, we want to say file not found. So that is to say, if this is not a file, if this is not a file, all right, we want to say the file that the user wants to rename does not exist, and then we'll also log that into our log file, and then end our if statement, and then end the case for that condition. Right? And then this asterisk stands for every other condition. So if the user does not does not type in rename, list, delete, or create, right, does not pass any of this option, what we want to do is we want to tell the user that this is the usage of this script. We need to provide the name of the script, and then any of this value, and then pass in the name of the files, right, and then log this to our file. So this is how the script is going to work. So you just want to save this. I want to save this and then run the script and see. So we want to start by creating, let's create a file called sample.txt. So you see the file was created, right? So say I want to create the file again. You see it is going to say the file already exists, right? So then what if I want to list the content of the file? I'm just going to say list. So I'm just going to use list. Mind you, we are using the script that is inside this file manager. Right, so I'm not even spelling the file manager correctly. I'm going to change that later. So list, you see it lists all the contents of my current working directory. So I then still go into after listing, we then want to rename. Let me rename sample.txt file to, let me say, sample1. Right, so you see that sample1 has now been renamed to sample1. So what about delete? So I'm just going to delete the file. Delete sample1.txt. You see that the file has been deleted, and I use the 3 command. You see that the file does not exist. So I think I'm not spelling the file manager correctly, so I'm just going to rename that. So I'm just renaming that file. So let's go on to the next question. So the D question is the backup.sh file. So we're going to create another file called backup.sh, and then the requirement is for us to accept the directory as input, validate the directory exists, and then create a compressed backup, right, using the tar command, and then want to store the backup inside the backups folder. So let's go into my repo that I've already created, and then copy the backup script. So I'm gonna copy all of this and then go back to my terminal. And then inside the script file, I want to do a VI bin, and then create the backup file, backup.sh script. And then I've just pasted all that I have just copied. So in this case, we still have to arrange the contents of this file. So let's delete one, So first and foremost, while calling the script, we need to have our source directory, which is going to be in the first position parameter, right? So we're going to be passing a source directory that we want to back up and then compress. So our location where we're going to be saving the backup is in the backup folder, right? And then we need to go one step upwards, and then the log file is going to be in the logs folder. And then what we want to do at first is to check if the source directory that's been passed in the first positional parameter, if it is not a directory, right? So if it is not a directory, we want to echo directory does not exist, and then log that to our file, right? And then also echo the usage, right? So I'm just giving the user, some information around how it's supposed to use the script. So this $0 is the name of the script, and then this is the source directory. So I'm just telling the user to provide the name of the script and then the directory they want to back up and then compress. So still also want to log this, right? And then want to exit with an exit of 1, meaning they exit the file, exit the script with an error, right? And then want to close our if statement with the F5. So we're then creating a timestamp, right, which we are going to be using and in the name of the backup that we're going to be created. So we're going to be using the date command and then formatting the date to contain the year, the month, the day, and an underscore, the month, the day, underscore, then the time, which is hour, minute, and seconds. So the backup file now is going to be within the backup directory, right, which is this that we've specified, and then /backup, and then the timestamp, which is this that we've just created, right, and then .star.gz, which means this is the tape archive, and it's going to be compressed with the gzip. So I'm just creating the name of our backup that is going to be created. Why are we doing this now? Because we are going to be needing it when using the tar utility to create a backup. So after creating the file, the backup name, we then want to use the tar command, and then use these options to create a backup file, right? The backup file is this that we've just constructed, and then this is the source directory, meaning we are telling the script that this is the folder that we want to compress and then zip. So the tar utility is going to be used to create the backup file for us. So, and these options, the -c means create, and z means zip the file that you're going to be creating, and then f is specifying the name of the backup file that we're going to be creating, and then this is the source directory. So after that, we want to echo the file has been created, and then we want to log that to our log file. So, and then we want to also keep only the last 5 latest backups, and then delete every other older backups. So to do that, we're going to use the ls command. So the ls command always prints out the result on the terminal. So we're just going to use the ls command and then go into the backup directory, right, which is this backup directory, and then fetch all the backup files. As you know, all the backup files are going to contain the same name except the difference of the timestamp, right? So we're going to list all of the files, all of the backups within that directory, and then pass that to the tail command. So this tail command is now going to be selecting only so this tail command -n and then +6. What this is doing is that it's going to skip the first five rows and then select every other row from 6 onwards, right? So if you have 10 files, this is going to skip the first 5 and then start selecting from number 6 up to the end of the file, and then pass that to the xarg command. So the xarg command is a utility that takes in input from the pipes, right, and then passes it to the rm command. So what this is going to be doing at the end is just deleting every other files apart from the first 5 roles, right? Apart from the first 5 files, which are the backup files, right? So which is our requirement. Our requirement is to keep only the latest 5 backups, right? So after doing that, we just want to echo clean up, right? And then log all the backups cleaned up, and then log that to our file. So that is how this file works. I'm just going to save this and then run that backup and see. So I'm just going to run backup without passing any argument and see how. So you see, I'm going to be having this error message and then information around how to use the file. So let's use it correctly. So I'm just going to be backing up everything within the script folder, which is my current directory. So as you can see, the backup has been created and the timestamp, right? So, and it's now logging, it's now printing all backups cleaned up, right? So let me just use the 3 command to see if that backup has been created. So it has been created, all right. So after that, we're just going to be going on to the next assignment instruction, which is process monitor. So the process monitor is going to be used to accept a process name as input and then check if the process is running. And then if process is not running, we're going to attempt to restart and then run. Output is going to be running, stop, and restart. Right, so and then we're asked to use an array, right? Use an array in this form, right? And then log every result into a log file. So let's just go into the file process monitor and copy what we have right there, and then we're going to be explaining that as well. So I'm just going to be creating the file process underscore monitor .sh, and then I'm going to be pasting what I just copied, right? And then as usual, I'm going to arrange the formatting. So I'm going to quickly explain how this works. So this is the location of our log file, process monitor, and then services. So we're just declaring an array called services and then passing this array just as in the instruction. And then we're going to be using the for loop, right? And then we're going to be checking for service in this array, right? What do we want to do? We want to use the pgrep command to get the process ID of that specific process. And then what we want to be doing after that, because we know the pgrep command always prints to the terminal, so we don't want to print to the terminal after fetching the process ID. We just want to redirect that into /dev/null. So redirecting it into this folder is going to be like we are going to be redirected into the trash can, right? Because everything within this directory gets automatically deleted by the system, right? So basically we're just going to be checking if these processes within this array is what, if they are running. So that is why we're using the pgrep command. And then why are we not using the ps command? So the ps command actually lists everything, while this pgrep command is going to be using the -x, and they will provide the name of our process, right, to get the ID of the command. So after, when we get the ID of command, the ID of the process, definitely then we know that the process is running. So after that, we're then going to, we don't want to print those IDs, we just want to delete them, right? And then echo the service is running, and then put that to our log file. Else, if there is no output, that means the process is not running, we want to say that the service is stopped, and then we'll just echo this, right, and then log that, and then we just want to simulate a restart, right? So we're not writing any command, we're not restarting the process, we just want to simulate, because that is one of the options that was given. We can just simulate that. So that's why we're just putting a comment around that within the script, and then echoing restart. Run the script. So you see it outputs Nginx stopped running, right? Nginx restarted and all of that, and then Docker. So mind you, if the processes were running, actually they are going to just show you that the process is running. So let's go on to the next task quickly. The next task is to create a run all.sh file, which is going to be used to run all of this, all of the commands, right? And then we're going to be including this, which is going to make our script a bit more robust, and then we are going to be logging that into our app.log file. Alright, so we're going to be providing an interactive menu that when the user selects 1, we're going to run all the processes. When they select 2, we're going to run the system check script, right? 3, we run the backup script, and then run 4, we're going to be exiting the script. So let's just go on and copy the script that I have already, and then I want to be creating that. So I'm going to quickly explain how this run all the script works. So as usual, we're going to have a logs file, which is going to be called app.log, right? And then we're going to be having this function, the run all function, which is going to call all of our scripts, right? So when the user wants to run all of the scripts, we're going to be calling this run all function, right? So have another function called menu, which is going to output all of this echo command in order for the user to select a particular menu. All right, by selecting 1, 2, or 3 to perform a specific operation. So this is actually where the logic is going to be start from, right? So we're going to be starting with the while command, and then we're saying while true means we're always going to be running this function, right? This command, because while true, it is always going to be true, right? So then we want to run what? The menu function. So we are calling this menu function to display to the user to select any of these options, right? After selecting, after printing that to the screen, we then want to prompt the user to tell them to choose an option, right? And then we're going to be saving the options they select in the choice variable. So case, I'm going to use the case to switch and then compare what the user has selected. Okay, so in case they select 1, which is run all, we're going to be running all the scripts, which are all of the scripts here. So I'm going to use bash to call all of the scripts. So in case they select 2, we're going to be using 2 to run the system checks, right? Which is going to be within this folder script/system checks, and then we're going to be logging the output right here. And then the third option is to run the backup script. So the third option is backup. So when the user selects 3 or type in 3, we're going to be running the backup script and then logging it into this file. And then only when the user selects exit do we stop prompting the user to enter a value, right? So we're then going to exit with the status code of 0, which means we are successfully or gracefully exiting the script. And then this asterisk sign stands for every other option. That means the user does not select any of these options. We then want to echo invalid options, right? And then end our case statement, and then end our while loop. So we're just going to run this and see how they work in action. So this is the option that's going to be So I just click enter again. So this is just to tell you that so long as you do not click on exit, you are always going to be prompted to provide an option, right? So let me select 4 just to exit this. You see, I'm just going to exit that. And then when I run the command again, and you decide to say run all system check or backup. So let's start with run all, which is option 1. Click on enter. You see all of this information has been provided for me. So we are now going to be running all of the scripts, right? So but then the first script for that user info has a prompt within it. So it's now going to be prompting me to provide my name, right? And then my age, and then my country. So after providing that, it's now giving me an output, right? So this is the output of that script. So all of our script now have been executed, and they have provided outputs. So but then these options are always going to be printed to you, and you're always going to be printed to select an option, except when you exit the loop using code number 4. So let's try in 2 so that we can run the system check. So I just noticed an error within the script file. So in this, while running this script, we're not supposed to add the script part because we are running this command from within the script directory. So I'm just going to save this, quit, and then run all. So I'm going to be selecting the second option, right? So you see you have all of that. So the third option now, which is a backup. So a backup has been created. So all of these are working. So we just want to exit, and so we just completed that part of the file. And so we're also asked to include this at the top of the file, which has been included. And then the logs are supposed to be in the app.log file. So let's just check the 3 command to just make sure that folder has been created. So the app.log file has been created, and I'm very sure it's been populated. So that is that. So what we need to do next is to go on and then commit these changes that we've done to this project using the git add command. So I just want to go back to the project, the root of the project first, and then use git status. So you see we've made a lot of changes in all of these folders, right? And they are not being tracked. So we want to use the git add, track all of our changes, and then use the git commit command, commit -m to commit all of these changes using this commit message, right? So we just want to pass in this commit message, right? So all of those files have been created, and then what you want to do next is to push to your origin, right? So we just want to say git push origin, git push origin feature/student. Remember, we are using the feature/student branch, and this student section is going to be replaced by your own name, right? So we just successfully pushed that branch to our remote Git repository. So what you want to do next is to create a pull request. So let's go back to our repository on GitHub and then check our progress. So you are going to see that the future/student branch has now been uploaded to my GitHub account. And what I can also do now is I can create a pull request. So when creating a pull request, you just want to add in some description, right? And then if you have images you want to add, just click on this button and then click on create pull request. So this pull request is going to directly go into the instructor's GitHub account, which is TSA, TSA DevOps/bash assignment. So this is not the branch I'm going to be submitting. So I'm going to be submitting in that submission later. So after doing that, you want to click on this link, the submission link, and then it takes you to this form where you are supposed to provide your name, your email address, and then the topic, and you may just select others and say bash. Bash assignment, right? We don't have any file we're uploading, and then right here you're supposed to provide the link to your GitHub branch. So let me just show you how to do that. So right here on your GitHub account on this project, you want to select this drop down and make sure that you are at selecting the branch you want to submit, and then you go to the URL. You're going to say that the URL will match the branch that you've worked on. So just copy that URL and go back to the submission page and provide that right here. Right. And then you want to add any additional information if you want to. So you just want to confirm this, and then please make sure that you are going through the code, right? Going through all of the script, and then you're making sure you understand them, you understand everything right there, and then making your own tweaks to make it different from every other person's assignment. So thank you for watching, and then I'll see you in our next meeting.